So we talk about Wi-Fi 6, Wi-Fi 6E. That's going to be the topic of the day. One of the things that people often get concerned about is they kind of throw their hands up and go, "Oh, geez, this is another technology. Is another technology I have to deal with." I thought we just went through this. I thought we just went through an upgrade a couple of years ago, and it does seem that way. It seems like the upgrade cycles and technology cycles are coming rapidly. So what's happening in terms of these upgrade cycles, Mitch? What's going on here?
I mean, we get improvements each and every time we have an upgrade, we have an improvement. So, you started off in 802.11b, right? We had a 2.4 network. Clients had very low throughput, but I mean, it was functional, right? It provided some use. But then we kind of said, hey, we need more bandwidth, right? We always want more power, to quote one of my favorite comedians. So we come out with the G standard, right? So we got a little bit more out of that 2.4, a little bit more throughput. We had to be backward compatible for the B, so that kind of dragged us down a little bit, right? So we said, okay, we don't like that. We don't like being dragged down. What we can do? Well, hey, let's move to a different frequency. And so we come up with 802.11a, and we opened up the 5 gigahertz band for that. And that was rocking along pretty well, right? But again, what happens? Our users want more power. They want to be able to do more throughput. We start streaming video, we start watching YouTube and Netflix and stuff like that. And so we say, ooh, okay, well, we're limiting ourselves. So let's come out with the next standard. Well, we said, well, what can we do? Well, how about we bond some channels together and give us a wider bandwidth, right? So 802.11n, right? So we had that quick jump. Mm-hmm. Well, and we like that channel bonding, but it really just wasn't quite working the way we wanted to. So then we said, well, what if we could do contiguous channels with the same capability? And so we come up with this whole thing of like, okay, well, that 5 gigahertz, right? We got a lot of frequencies there. So we said, hey, why don't we come up with 802.11 AC? And so now we have, 80 gigahertz channels and 100, and in some cases you can kind of get up to 160 gigahertz channels on some equipment. But we went from a 20 megahertz to a 40 megahertz to now an 80 megahertz, right? So now we're putting more through, right? And so we allowed for clients to be able to multiple clients receive broadcasts, but we're still kind of limited in the AC where it's kind of a 101 up, right? So, well, wow, everybody wants everything wireless. Wireless is almost like air and water, where, if I don't have air and water, I'm not alive. So I need something more. So now we've come up with this 802.11ax that kind of solves those contention problems that we had in AC. And then in turn, utilize that 5 gigahertz band even better with more protocol standards on top of it.
So I really liked the 11AC part of that cycle myself. It worked very well. As you mentioned, channel bonding, but also brought in some other new things. Another jump in the QAM up to 256 QAM, which gave us a 30% improvement on how densely we can pack the bits per symbol. So we jumped up 30% in our bandwidth just right off the top with that. But also 11AC did a lot of nice work around a standardized transmit beamforming. So now we have a standardized way of doing it instead of proprietary ways. And so there's more control now over transmit beamforming. And that technology has just, has replicated through all 11AC technologies and generations. And that standardized transmit beamforming continues on into Wi-Fi 6 and 6E. That was a big boost by getting to that standardized way of doing beamforming. 11AC also did a nice thing with packet aggregation. So we're taking all those small response packets and acknowledgments or not acknowledgement, NACs or NACs and ACs, and combining them, right? Combining them together and then being able to transmit a whole bunch of data and then let the client respond back to the bulk data instead of responding to each packet. So that improved 11AC quite a bit. There was a big jump. So why, so let's talk about this jump, the next jump, right? The one that we just went through. where I say we're going through it right now, which is 802.11ax. If 11ac is so good, it's got all this transmit beamforming, it's got wide channels, it has efficient packet aggregation, higher density symbols. What's going on with 11ax? What's the top? Give us a quick summary. And we have talked about this in a previous webcast. We don't go into too much detail, but tell me what's list off the top 1, 2, or 3 features of AX. That's some big
So,
improvements.
first you have OFDMA, which allows multiple access,
Mm-hmm.
right, for multiple clients, which really you had downward to multiple clients in AC, but you didn't really have upward to multiple clients. And whereas 82.11x takes care of that issue of allowing for that bidirectional capability, right? So that was going to reduce some of our latency issues and some of our contention issues, and just overall airtime utilization. That's one really big key thing. The other thing that AC didn't really do, I mean, it does well, but I mean, it's not going to do as well as AX is. Now we got density, right? I mean, stadiums, large deployments. How do we take care of that near far problem? Where if I'm a client at an edge where I hear my AP, but then I can hear that guy that's a little bit further away communicate. Well, I got to stop. I can't talk, right? So well, we got those resource units, got the OFDMA. Well, what are we going to do about this? Well, we come up with this idea of a color code, which is really just a number associated with a particular AP. So that way it puts it in its beaconing and its transmit. So that way I know that I'm going to pay attention to you. Because when clients are broadcasting to an AP at the same time, they're not really interfering with each other. Right, because when I broadcast, I could care less what you're broadcasting. My AP has to worry about if it can hear the other broadcast. So I mean, now I'm opening that up in the sense of I'm able to handle more clients, more packets, more just in general, more communication cycles from a network from a cell size of that particular AP. So I mean that's a big key kicker between the AX and the AC is just that alone, allowing for that capability between the color code and the OFDMA.
Okay. Yeah. Okay.
Yeah, there's yeah.
Yeah. So these things are all around this aspect of making it more efficient, right? That's what it's all
Yep.
about. And so let's map that a little bit, that efficiency into the applications, and how things have changed in the last, 3, 4, 5, 6 years, 5, 10 years. So we've had, if you go back historically, you look at, tablets started in 2010, with the iPad. Now everybody's got a tablet, and tablets have, for a while there, they thought tablets were going to, kick laptops out of business, put them out of business. Laptops have come back, right? Laptops are stronger than ever. And so now we have laptops, we have tablets in the network, we have smartphones. Those are different types of devices we have. They're all contending for access. And then we have 2 other aspects that really impact the network, 2 other things to talk about. One is the always connected social media, right? So social media used to be something you checked once a week, twice a week, then it was every day, then it was a few times a day, and now it's always on. It's a 24-hour a day cycle, right? The news cycle and social media with with TikTok and Twitter and your Facebook feeds and all the different things that might impact us. We're on the WhatsApp groups. It's a constant barrage of 24/7 social media presence that creates potential for contention. It's an application that needs to be accessible. Other thing is streaming media, streaming multimedia, and think about the last time you traveled in a hotel. Did you stream Netflix or HBO Go or something else? You probably did. You probably did in your hotel. So now we have to deal with streaming media at different bit rates. So Wi-Fi 6 has to deal with all of those issues, right? It has to deal with more devices in the network, doing more things than ever before, and sometimes at very small packet sizes. And that's the challenge. And that's how we lead to this concept of higher efficiency. More devices, doing more things, oftentimes very small packet sizes. So that's what's the problem we're trying to solve there with Wi-Fi 6.